Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to see the topic indeterminate form and how to solve the indeterminate form by using the L'Hopital rule. Now, in this one, first we have to know what is the indeterminate form. When you apply the limit for any function, if you will get 0 over 0 or infinity over infinity, we call it this one as an indeterminate form. And how you will solve this type of problem. So there are one method. If you have a polynomial, you will get 0 over 0, we can just factorize. And there is another method we can solve by using the L'Hopital rule. So how the L'Hopital rule works? So here, so you have to differentiate the numerator and denominator separately and apply the limit. If you will get a finite value, stop the process. If it is not, again if you will get a 0 over 0, you have to repeat the process until you are not getting the finite answer, the finite form. So let us go to the problem. Inshallah, you will find it the procedure. Before going to solve the problem, we have to know the basic concept. The x power 0, 1, x power infinity is infinity, 1 over 0, infinity, 1 over infinity, 0, e power 0, 1, e power infinity, infinity, e power minus infinity, 0. And this is the e to the power ln x. If it get cancelled, you will get only the x value, only the x value. And here, this is the len infinity. So len of infinity, which is equal infinity, len of 1, which is 0, len sine 0 0, cosine 0 1. Now let us go to the first problem, the example. This is the example you will have for 0 over 0 indeterminate form. Limit x approaches to 1, x minus 1 over x square minus 1. If you apply the limit 1 minus 1, that is 0, in the numerator over denominator 1 minus 1, which is 0. So therefore, you will get an indeterminate form. Now, how will you solve before? So we will solve before as using the factoring. So what is the factoring here? So you have to factor the denominator. What is the factor in the denominator? X plus 1, x minus 1. Now therefore it get cancelled. X minus 1, x minus 1 cancel. You will have 1 in the numerator. So when you apply the limit, you will get 1 over 2. So therefore you will get the final answer by using the limit concept. Limit concept. Now we will solve the same problem using L'Hopital rule. So you will get an indeterminate form. What you will do next step? So limit x approaches to 1. So therefore I have to differentiate the numerator separately. When you differentiate numerator, x become 1 minus 1 becomes 0 since it is a constant over. Now what about the denominator? So here x square as 2x minus 1 becomes 0. Now you will get this function after differentiation. So now you will apply the limit. If you apply the limit, what happened here? 1 over 2 times of 1, which is equal 1 over 2. So the same answer you will get it by using the factoring method, by using the L'Hopital rule. So we will solve the next problem by the infinity. What will do for the infinity? So the infinity case, when you apply the limit, you will get infinity. Here, infinity over infinity, which is an indeterminate form. And how will you solve? By using the limit. So I will take the highest power. What is the highest power in the numerator? Therefore, it is x square. I will take x square in the numerator. I will take the 2x square in the denominator. So if you simplify, so x square with the x square cancel, you will get 1 over 2. So limit x approaches to infinity, which is equal 1 over 2. If you apply the limit for a constant, you will get 1 over 2. So this is the final answer. Now the same problem we will solve by using the L'Hopital rule. So the L'Hopital rule, so if you apply the limit, you will get infinity, infinity, therefore which is indeterminate form. What is the rule for the L'Hopital rule? You have to differentiate the numerator and denominator separately. So while differentiating the numerator, you will get 2x, whereas in the denominator, you will get 4x. X with the x cancel, and here 1 time, this is 2 time. When you apply the limit for a constant, limit x approaches to plus infinity, 1 over 2, which is equal 1 over 2. Same answer you will have. And what is the condition for applying the L'Hopital rule? It must have the indeterminate form 0 over 0 or infinity over infinity. This is a perfect example we will have by using the factoring and highest power, and both the problem we solve by using the L'Hopital rule. Let us go to the next problem we have. Here the same thing, I have to apply the limit first. When you apply the limit, root 4 which is 2, 2 minus 2 which is 0 over, when you apply the limit in the denominator, x minus 4 which is 0 over 0 when you apply the limit. So it is an indeterminate form. I say it is indeterminate form. Apply L'Hopital rule. Apply L'Hopital rule. L'Hopital rule. When you apply the L'Hopital rule, what happened? Limit x approaches to 4. When you differentiate the numerator, root x, which is 1 over 2 root x, 2 becomes 0 over. Here, x differentiation 1 minus 4 becomes 0. So here we have to remember this rule, that is you have to differentiate numerator separately and denominator separately. There is no f over g rule here. Most of the students make a mistake here. They apply f over g. It is wrong. So you have to differentiate numerator separately, differentiate denominator separately. When you apply the limit, you will get 1 over 2 root 4. So which is equal 1 over 2 times of 2, which is equal 1 over 4. So this is the final answer. Now we go to the next one here. So here this type of function we cannot solve by using the limit because it has the exponential trigonometry function. So here if you see this part, whenever you have a polynomial, you can just factoring. But this kind of problem, it must have to solve using the L'Hopital rule. There is no other method to solve. Now, we will apply the limit. When you apply the limit, t approaches to 0. So, e power 0, which is 1. 1 minus 1, which is 0. Here, sign 0, 0. Therefore, you will get an indeterminate form. Now, apply L'Hopital rule. Apply L'Hopital rule. So you will get limit t approaches to 0. What is the numerator you have? E power 2x. So this is a chain rule. When you differentiate 2t, it becomes 2. The 1 becomes 0. This is done, the numerator part. Over. Denominator is what? Sine t, which is cosine t. Now apply the limit. You will have 2 times of e power 0, which is 1, over cosine 0, which is 1. So the answer will be 2. So here we are using the chain rule. Here we are using the chain rule for differentiating because it is e power 2t. Now the next one we have the limit. If you apply the limit, x approaches to 1, 1 minus 1, 0, sine 0 is 0, over, here you will have 1 plus 1, which is 2 minus 2, so 0 over 0. So it is an indeterminate form. Now I have to apply the L'Hopital rule. Apply L'Hopital rule. L'Hopital rule. So limit x approaches to 1. Limit x approaches to 1. Differentiate numerator and denominator separately. So when you differentiate the sign, it becomes cosine x minus 1. Product. Here also the chain rule. So this is done. This is the first part is done. What about this part? So when you differentiate the inside, x differentiation is 1. Over. What about the denominator? So it is 3x square plus 1. 3x square plus 1. Now apply the limit. When you apply the limit here, cosine 1 minus 1, 0, cosine 0, over here 0 plus 1. So cosine 0 is 1, 1 over 1, which is equal 1. So this is the answer. Now the next one we'll see. One second. So here you have to substitute the limit as 1, not as a 0. So here you have to substitute the limit as 1. So not as 0. Therefore, you will have the value, the limit x approaches to 1. Therefore, 3 times of 1 plus 1, which is equal cosine 1 over 4. So 3 plus 1, 4. So it is 1 over 4 is the correct answer. Now the next part we will do it. Limit x approaches to 0, e to the power x plus e to the power minus x minus 2 cosine over sine x into sine x. So when you apply the limit, you will get e power 0 is 1, e power 0 is again 1, minus cosine 0 is 1, which is 2, minus 2 over here sine 0 into 0, which is 0. Therefore, you will get 0 over 0 form. So which is an indeterminate form. Apply. So here I have to apply L'Hopital rule. Apply L'Hopital rule. What is the rule here? I have to differentiate the numerator and denominator separately. So what is the differentiation here? E to the power x, e to the power x, done, plus e to the power minus x, but here when you differentiate minus x, it becomes minus 1. It's a chain rule. Next, minus cosine differentiation plus 2 sine x over here when you differentiate the denominator, you have to apply f into g, product rule. So because it is in the product, so x differentiation 1, sine x as it is, plus x will be fixed, sine differentiation cosine. Now I will rewrite this step first. After that I will apply the limit. So limit x approaches to 0, e to the power x minus e to the power minus x plus 2 times of sine x over sine x plus x cosine x. When you apply the limit, what happens? E to the power 0 is 1 minus e to the power 0 is again 1 plus sine 0, which is 0, over, so here sine 0 is 0 plus cosine 0 is 1. Along with the cosine 0 you will have x, therefore it is 0. So you will get 0 over 0 again. So you have to apply one more time the L'Hopital rule. Repeat the process until you are not getting the finite answer. This is the idea of the L'Hopital rule. So you have to differentiate continuously until you will not get the final answer. So here we will differentiate one more time. So what is the differentiation here? What is the differentiation? So I have to differentiate this part. What is this part? Again, L'Hopital rule you have to apply. So here the L'Hopital rule says, so I write it here. Limit x approaches to 0. Now here I will write it. E power x, it will be e power x minus e power minus x. There is a chain rule minus 1 for this part. Next, plus sine differentiation is cosine differentiation. Next, when you differentiate the sine, you will get here cosine x. Now, therefore, when you differentiate the second part, you have to apply f into g. So, product rule 1, cosine will be fixed, plus x will be fixed, cosine differentiation minus sine. So, now I rewrite this step first. So, x approaches to 0. Here e to the power x minus of minus plus e to the power minus x plus 2 cosine x over cosine and cosine. So it becomes 2 cosine. So this is 2 cosine. You will have 2 cosine. This one minus x sine x. Now apply the limit now. So when you apply the limit, it becomes cosine 0 1 plus this is e power 0 1, e power 0 is 1. plus cosine 0 is 1. Along with the 2, you will have 2 over. Here we will have cosine 0, which is equal 1, minus sine 0 is 0. So therefore 4 over 2, answer is 2. So you will get a finite value. Stop the process. If it is 0 over 0, you will continue the process until you are not getting the finite answer. So this is the idea behind the L'Hopital rule. Now let us go to the next problem. We will see what happened. Limit x approaches to 0, e to the power x plus e to the power minus x. Here also the same thing we will do it. When you differentiate this part, you have to apply the chain rule. Let us go. So here it is 0, it is 1 plus 1 minus 2 over 1 minus 0 minus 1. So it is 0 over 0, which is an indeterminate form. Which is an indeterminate form. Now apply the rule. So what is the rule here? So apply L'Hopital rule. When you apply the L'Hopital rule, limit x approaches to 0. So differentiate the numerator and denominator separately. E to the power x, e to the power x. Here you will get the chain rule. I said e power minus x is minus x. When you differentiate x, it become minus. Therefore, it become minus. I multiply directly. And minus 2 becomes 0. Now what about the denominator? E power x is e power x minus 1 and 1 becomes 0. 1 become 0. Now when you apply the limit for this part, so what is the remaining? I write it here, e to the power x minus e power minus x over e to the power x minus 1. When you apply the limit, e power 0 is 1 minus e power 0 is 1. Here 1 minus 1. So you will get one more time as the indeterminate form. The rule says again you have to apply the L'Hopital rule. So I will apply one more time. So what is the one more time here? Apply L'Hopital rule again. So limit x approaches to 0. And here what is the differentiation in the numerator? So in the numerator you will get e to the power x, e to the power x. While differentiating this part, it becomes e to the power minus is there, e to the power minus x, it become minus, therefore it become plus. So it's a chain rule. It's a chain rule. Now e power x, it is e power x, 1 becomes 0. Now apply the limit. What happened? E to the power 0 is 1 plus e to the power 0, 1 over 1. So therefore the answer will be 2 over 1, which is equal to, is equal to. If it is 0 over 0, I have to continue one more time. So this is the idea behind the L'Hopital. Now let us go to the next problem, which is the three types of a special problem we say. So what is the condition for applying the L'Hopital rule? It must have 0 over 0. When you apply the limit here, it is not 0 over 0. It becomes infinity into infinity. So I have to adjust this function in such a way that you will get an indeterminate form. How will you do this one? So I will do it. Limit x approaches to infinity, sine pi over x. So I can write it this over this x as 1 over x. Is it same? Yes, is it same? So why? The denominator of denominator, it goes to numerator. So this is the same thing I have done. Now same function, you can write it this part or this one. Same. Nothing changed. So why we are changing this one? Because I have to get the infinity over infinity. That's why. When you apply the limit, it becomes e power infinity is pi over infinity 0, sine 0 is 0 over. What about next one? You will have sine 0, 1 over infinity, which is 0. So it is 0 over 0 form. Indeterminate form. I apply the L'Hopital rule. Apply L'Hopital rule. When you apply the L'Hopital rule, differentiate the numerator and denominator separately. When you differentiate the sign, it becomes cosine pi over x. Done. This is done. When you differentiate inside pi over x, So it is minus pi over x square. How will you get this part? So it is the same idea. You have 1 over x differentiation. Suppose k. I say here pi itself. Pi over x. How will you differentiate? Pi is a constant. If you bring it up, it becomes minus 1. So what is this part? Minus 1 into x power minus 2. When you write it in the proper form, pi over x square. So this is a derivative of pi over x. The same thing. Over. Same thing. 1 over x, it is minus 1 over x square. Bring it up and then apply the same rule. You will get minus 1 over x square. Now, what are the terms get cancelled here? So, here the cancelled term, you will find it. The cancelled term is here. Minus with the minus, first cancel. X square with the x square cancel. What is the remaining part you will have? Limit x approaches to plus infinity. You will have a pi cosine pi over x. When you apply the limit as x approaches to infinity, it becomes infinite pi over infinity, which is 0, cosine 0 into pi. So cosine 0 is 1, so it is 1 into pi, which is equal pi. So this is the final answer. Now let us go to the next problem. These are the three types of a special problem we say. This is the one. You have to write it this part. This is the number 2 and this is number 3. Now what is this one here? So you will apply the limit. You will get 1 over infinity, which is infinity. 1 over 0 is infinity. 1 over 0 is infinity. Infinity minus infinity. So I have to make it this one in the proper form. Just cross multiply. What happened? Cross multiply. You will have x e to the power x minus 1. When you cross multiply, you will get e to the power x minus 1 minus x. So this is the same function. Either you can write it this like this or you can write it this one. So I will take this part to do the L'Hopital rule. When you apply the limit, what happened here? When you apply the limit x approaches to 0, 1 minus 1 minus 0 over. Here 0 ala tool 0. Therefore you will get 0 over 0. It is indeterminate form. Now I have to apply L'Hopital rule. L'Hopital rule. Limit x approaches to 0 plus. That is the right limit. This is the right limit. Now here differentiate the numerator and denominator separately. What is the differentiation here? E to the power x minus 1 becomes 0, x become 1 over. Here you have to use the product rule. X differentiation is 1. E to the power x minus 1 is a fixed plus x is fixed. When you differentiate e power x, you will get e power x. We have to apply the product rule in the denominator. Now, I will simplify this part first. After that, I will apply the limit. If it is 0 over 0, then it is easy to do it again. E power x minus 1 over. So, e to the power x minus 1 plus x e power x. Now, apply the limit. So, now apply the limit. When you apply the limit, what you will get? Here, e power 0 is 1. 1 minus 1, 0 over. Here 1 minus 1, 0, it is 0. So therefore you will get the indeterminate form again. So what is the procedure? I have to do it the L'Hopital rule one more time. I have to apply one more time. Apply L'Hopital rule again. When you differentiate this one, limit x approaches to 0 plus. Here e power x, 1 becomes 0 over. Here e power x is e power x. This one becomes 0 plus this one becomes 0. I have to apply here the product rule f into g. So this is the same rule 1. E power x is a fixed. X is fixed. E power x is the differentiation. Now when you apply the limit here, what will you get? So you will get here. You will get this part. Yes. Apply the limit, you will get numerator 1 over. What about this part? E power 0, which is again 1, plus e power 0, again 1. And here e power 0 is 1, but along with this one it is x. When you apply this one, entire part will be 0. So this is 0. So you will get the answer as 1 over 2. That's it. 1 over 2. Now the question is here the power. So whenever you will have a power, I have to take a len. So I will take this part as a y. The given question as y equal 4 times 4x plus 1 to the power cosine x. Now take len both side. When you take len both side, len y equal, this power will be bring here cosine cotan x into len of 4x plus 1. Now the same thing I have to rewrite the function as len 4x plus 1 over this part. I can write it as, I will bring it down, it becomes tan x. It is tan x. Now apply the limit both side. Apply the limit both side. What are the limits here? So you have a limit x approaches to 0 plus, and here x approaches to 0 plus the right limit. Now when you apply the limit here, e power this is 0, len 1 over tan 0 is 0. Therefore, you will get 0 over 0, which is an indeterminate form. Apply L'Hopital rule on right side. You can apply only on the right side because it is an indeterminate form. You will get only on the right side. So this is going to be a same. Limit x approaches to 0, len y will be the same. Equal. When you apply this one, what is the derivative for the numerator? The derivative is 1 over 4x plus 1. This is a chain rule actually. First you have to do the len, then inside. When you do it the inside, it becomes 4 over sine differentiation is tan differentiation is 6 square x. Now apply the limit on the right side. You will get here 4. This part becomes 0. This part become 0. So when you apply the limit, you will get 4 in the numerator over secant 0 is 1, which is equal 1. So you will get 4. But this is not the answer for the y. Here you have a len. So I have to take this part as remove the len. How will you remove the len? There is a technique. I have to raise the power both side by e. When you are raising the power e both side, e to the power e. So now here on the left side it get cancelled as per the property. Now here you will have x approaches to 0 plus, this is equal y equal e to the power 4. E to the power 4. And what is your y value? Y value is nothing but the question which is given here. The question here, this is a y. Now I just write it that part. Limit x approaches to 0 plus, y value is 4x plus 1 over whole to the power tan x equal, the answer is e to the power 4. That's it. So how will you identify this type of problem? Whenever you will have a power, I will take len. This is the idea. Now the last question of this topic, which is the limit x approaches to infinity x over square root of x square plus 1. When you apply the limit, it becomes you have infinity over infinity. But I will apply the limit here. So apply L'Hopital rule. Apply L'Hopital rule. When you apply the L'Hopital rule, you will get limit x approaches to 0, sorry, infinity. And here we will have the differentiation in the numerator is 1. What about the denominator? First you have to differentiate the root. When you differentiate root, 1 over 2 root x square plus 1. This is root done. What about the inside? The inside, if you go with the inside, into 2x. This is the into 2x. Now if you simplify, you will get what? Cancel. So it can be rewritten as limit x approaches to infinity. So this part it goes to the numerator. This part it goes to the numerator. Yeah. So here if you see this part, it goes to the numerator. So therefore the answer will be root x square, square root of x square plus 1 over x. So here you will get a reciprocal of the function. Again if you apply, you will get this function. So continuously you will get a same function, the original function, reciprocal function, original function, reciprocal function. It never ends. That's why here the L'Hopital rule. This is the perfect example where the L'Hopital fails here. So what is the at another steps we have? Another method. So as per the highest power. So here L'Hopital rule failed because you will get the original function and a reciprocal function. So I will use this highest power concept. What is the highest power in the numerator? X over. What is the highest power in the denominator? Root x square. So therefore it becomes cancel root n square. Limit x approaches to plus infinity. 1 over, that is x over x. X over x. So it get cancelled. So it is 1. When you apply the limit for the constant, it becomes 1. So therefore, limit x approaches to 1, which is equal 1. So here, this is a perfect example for which the L'Hopital rule failed. We will use the same technique by the highest power rule. So this is the problem. Thank you.